Good morning. Today I would like to take a seminar on the topic overview of LSTM. These are the content today I discuss LSTM architecture such as for forget gate, input gate, output gate, and finally applications of LSTM. LSTM stands for Long Short-Term Memory Network, and it is an advanced RNN. It is capable of handling the vanishing gradient problem. It is an advanced RNN and a sequential network that allows information to persist. It is capable of handling the vanishing gradient problem faced by RNN. A recurrent neural network is also known as RNN. RNN is used for persistent memory. This is an LSTM cell. And using the cell, we will understand how LSTM functions. And we can see it has three parts. Each parts perform different functions. In the first part, which chooses information from previous timestamp, it is relevant and it can forgotten. In the second part, the cell try to learn new information from the input to the cell. And in the third part, the cell passes the final updated input information from the current stamp to the next. And these three parts are known as gates. The first one is known as forget gate, and the second is input gate, and the third one is the output gate. That is, LSTM consists of three parts. The first part chooses whether the information coming from the previous timestamp is to be remembered or it is irrelevant and can be forgotten. In the second part, the cell tries to learn new information from the input to this cell. At last, the third part, the cell passes to the updated information from the current timestamp to the next timestamp. These three parts of an LSTM cell are known as gates. The first part is known as forget gate, and the second is input gate, and the last one is output gate. It is like an simple RNN. There is also have a hidden state. HT minus 1 is the hidden state and from the previous timestamp, and it is HT is the current timestamp. In addition, we also have cell state in LSTM. CT minus 1 and CT are CT are the cell states. It carry information along all the timestamp in the network. Uh, Here it's just like a simple RNN, as LSTM is also have a hidden state where HT minus 1 represent the hidden state of the previous timestamp and HT is a hidden state of the current timestamp. In addition to that, LSTM also have a cell state represented by CT minus 1 and CT for the previous and the current timestamp respectively. And hidden state can be considered as the short-term memory of the network, and cell state as the long-term memory of the network. Then let's see how the forget gate works. In a cell of LSTM network, the first step is to decide whether we should keep the information from the previous timestamp or forget it. Here it is an equation for forget gate. Ft equal to sigma xt star uf plus ht minus 1 star wf. Here xt is the input from the current timestamp, and uf is the weight matrix associated with the input, and ht minus 1 is the hidden state from the previous timestamp, and wf is the weight matrix associated with the hidden state. And here a sigmoid function, and ft going to be a number between 0 and 1. Then the output of the ft is then multiplied by the previous timestamp, that is ct minus 1. If ft is 0, then this product is also be 0, so it forget everything as the past. If ft is 1, then product is equal to ct minus 1, that is previous timestamp, that is cell state. The next gate is input gate. Input gate is used to quantify the importance of the new information carried by the input. In addition of useful information to the cell state is done by the input gate. Here it is a equation, it equal to sigma xt star ui plus st minus 1 star wi. Here we have ui and its output both lies between 0 and 1, because because of the sigmoid function. Here xt is the input at the current timestamp t, ui is the weight matrix of input, ht minus 1 is the hidden state at the previous timestamp, and wi is the weight matrix of the input associated with the hidden state. And the third gate is output gate. The task of extracting useful information from the current cell state to be presented as output is done by the output gate, and its equation ot equal to sigma xt star uo plus st minus 1 star w0. It is the equation of the output gate, and it is also similar to the previous two gates, and its values lies between 0 and 1 because of the sigmoid function. And now to obtain the hidden state st, and it will multiplied by the output ot by tan h of the updated cell, that is ct, and it's here its equation hd is equal to ot star tan h of ct. And it turns out the hidden state is a function of long term memory and the current output. If you need to take the output of the current timestamp, just apply the softmax activation on hidden state ht, output equal to softmax of ht. Then here this is a more initiative diagram of LSTM network. Here xt minus 1, xt plus 1 are the input and output of the sigmoid function control the tan h function. Then finally application of LSTM, that is language modeling, machine translation, handwriting recognition, image captioning, image generation using attention models, question answering, video to text conversion, polymorphic music modeling, speech synthesis, proteins secondary structure prediction. These are the applications. That's all. Thank you.